Recording live from BTON and Austin Reitmeyer's here today. All right. Test, test, test. All right, so let's get started. Your test, day one, starts Thursday. And so we'll go through Form B today and tomorrow. You'll do chapter review. That's due by Thursday or Friday, except for the multiple regression parts. All right, so in honor of Austin being here, said day consists of the number of years that the applicants for foreign service jobs have studied German and the grades they received on test. The following regression equation is obtained, where x represents the number of years, y represents the grade on the test. What does the slope of the line represent in terms of grade on a test? What's the slope mean? Here's years. Here's grade. What's the slope mean, 10.9? Not everybody at once. How do you write the slope as a fraction? Rise over run. So 10.9 over 1. So for every 1 that way, you're going to go up this way. So what's it mean if you go 1 year to the right and up 10.9 in your grade? Blake. Yes, but what specifically do the numbers mean? X is the number of years the applicants studied German, and then the grades they received on the test is the Y. Close. Not for every right answer, but for every extra year they study, their grades are going to go up 10.9 points. If they don't study at all, they can expect a grade of 31.6. If they study for 1 year, they can expect a grade of 41.6. If they study for 1 year. So the slope tells you how your grade will improve based on the years of study. That's what slope does. All right? The other day, or I think it was Friday, we talked about the independent dependent, the predictor, and the, what was the other word for it? Predictor and something else. So, not bad. Number 2. Given the linear correlation coefficient, R, and the sample size N, determine the critical values of R. What is the critical values of R, and how do you find them? What does this have to do with anything? Level of significance. Yes. Page, what page? 760. What do you need for your critical numbers? N and alpha on page 760. What is the critical numbers in if N is 9 and alpha is 0.05? 0.666 negative and positive 0.666. So what is, if you have your test statistic of 0.898, where will that fall in the region? In region number 1? In region number 2, or in region number 3? R equals 0.898 will fall in region number 3. So does that mean there is a correlation or there's no correlation? Here there is no correlation. Here there is a correlation, and here there's a correlation. Because in this one you're rejecting the null. So I believe the answer should be point plus or minus with no significant correlation. See? There we go. So you're going to do that on your own when you get the test.
With choices.
Absolutely not. All right, moving on. 1, 2, going to number 3. Why don't you give this one a shot at number 3 and see if you can find the value of the linear correlation coefficient R on your own. That means you, Wyatt. There you go. Rich, going to pick up a calculator also. Start typing things in. All right, so what'd you get? 0.708. Anybody else? Good. Lindreg t-test. You're looking for the R squared. You know you're doing Lindreg t-test because it says linear correlation. Oh, R. Sorry. There you go. Okay. All right. We'll use R squared later, but it'll tell you when to use it. All right, here we go. Describe the error in the stated conclusion. Given, each school in the state reports the average SAT score of its students. There is a significant linear correlation between the average SAT score of a school and the average annual income in the district in which the school is located. So they're saying if you graph out income versus SAT, there is a correlation. Conclusion, there's a significant linear correlation between SAT scores and family income. What's the error? Yes. Yeah, I think it would be average. And also, and the average annual income in the district in which the school is located. It doesn't say the annual income of the parents of the students. It just says the annual income of the town. So that might not transfer to the students as well. Right. It says annual income in the district, but it doesn't necessarily say family income, so you have to be careful about that. The wording in statistics is very crucial. That's why a lot of people want it taught in high school before you leave, so you understand how to read things that are critical. Okay? Just out of curiosity, what did they put down at the end for their answer? See if we were close. Same thing? Average is individual, and incomes does not necessarily imply a linear correlation between family incomes. Okay, so we're pretty close. All right, number 5, scatter plot. Do this one on your own, start to finish. Go through the steps on your own because you ask me and I'll say I'm busy. I really am. For those that won't be here tomorrow, we'll try to videotape the second part of this. Actually record it, not videotape it. So, you're going to put the information into input data. L1 and L2. If you don't stop, you'll leave. Input data L1, L2. Okay. If you took a look at the choices, which in this case we aren't going to use, but remember this is your X, well you can do zoom stat or you can do X max, sorry Y max, Y min, but zoom stat will be fine on the test. Which one is it? Is it? A, B, is C on the next page? Looks like C. Okay. You're just going to draw it? I'll be able to tell based on your scale and everything if you got them all. I'll also actually count, see how many you have, make sure you have all the data plots on there. Shouldn't be that difficult, I wouldn't think. Should it? Okay. All right. That's fine, but later on you're going to have to draw it. Okay. All right. Best predicted value. Remember, that could be Y bar or Y hat. How do you tell the difference between Y bar and Y hat? Remember, you're going to have two answers. Y hat equals 5x plus 2. Y bar equals, no, Rogo. Turn your book open. Page 760. So, are you going to use 5x, oh, sorry, 5 times 5 plus 2, Y hat equals 27, or you're going to use Y bar as 18.3. How do you tell which one to use? Yep. Somehow we're going to see if there's a correlation or not. If there is a correlation, we use Y hat. If there is no correlation, we use Y bar. If there is a correlation, we use Y hat. How do you tell what the critical values are? Clayton, what do you think? 760. N is 6. What's alpha? 0.05. So what's our critical value going to be? 0.811. Now, our test statistic is 0.44. That's our test statistic. How does that fall in the region? First, second, or third region? Second. So, since there is no correlation, we'll use Y hat as our answer. I'm sorry, Y bar. I said Y hat, I circled Y bar. Okay. So, you just have to do a correlation test, given your test statistic. Questions? Fantastic. We'll try to get to number 10 today before we stop. That was number 6. The answer was 18.3 Y bar because there was no correlation. Number 7. Do this one on your own. Find the equation of the regression line. You don't have to graph it. You just have to find it. All right, Austin, what'd you get?
What?
The A letter. What'd you get?
The A letter? No.
I got time. Nothing but. You think so? 3.79. What'd you get for B? Tyler? 0.897. There we go. Okay. Not difficult, just you have to make an attempt to actually get out your calculator, turn the buttons on, and input the numbers. Good. We're going to do the next one. Number 8. Oh, here we go. We never did get through this the last time. I'll give you a minute or not. All right. Is it an outlier, influential point, both, or neither? The x values run from 100 to 400. The equation is 38.4 plus negative 0.9x. Okay, what do you give you but 375 into this equation? Let's try to figure this out. Austin?
Got it.
Good. Good. Austin Rottmeyer's getting ready to double check. Negative 0.9 times 375. What is it? So you get the same thing as your new data point. So will this line change? If your new data point's on that line, is the equation line going to change? No. So I say it's neither an outlier nor influential. Does that make sense? Well, let's say you put something in, a new data point, and it was way up here. Wouldn't the line have to change to go get it? Wouldn't that change your equation? And if it's way up there, not even worth doing it, you just throw it out, that's an outlier. So influential, I think, means it's going to change your graph. Outlier means you can throw it out. And both means, well, you got a choice. Probably. So I would just give you an outlier. I don't have any scale right here, so it's tough to tell how big it is. Okay. What's the answer say?
Check it.
I don't know.
You got the key.
That doesn't matter. You guys won't have a key when you take the test.
Yeah, you got it right now.
8 says A. What did it say?
You put C.
Perfect.
So it's on
No, it's neither.
a, you must C.
No, it's not going to. I said it would be if it was up here because an outlier. We said it was neither. It's not going to change the equation or throw it out. It's on the line. The line's not going to change. If the new data point was higher, it'd move, it'd shift everything up. All right. So 2 more. 8. 9 is on the next page. Here we go. All right. After you made this, yes. Oh, okay. After you made this regression line, does it suggest that the equation is a bad model? What do you think? Right, it doesn't touch any points at all. I'll give you that. Anything else? As you keep going, what do you think these dots are going to do?
Get closer.
Do you think the pattern is for it to get closer to the line? So if you want to make a prediction past 6, it might not be a bad model or line to use. If you want to use it between 0 and 6, I'd say it probably wouldn't be a very good model to use. So I'd say it's not an entirely bad model. I'd say it's probably okay past 6, but definitely not from 0 to 6. It'd be a bad model. So I think that's why the why or why not comes into play. If you say it's a bad model, you have to say why you think it's a bad model. And he said because the dots don't touch, and I agree with that. But I also agree that if you keep going past 6, those dots are going to get closer to the line just by looking at the pattern of them. Could they go back up? Sure. But as long as you make a case for it, you can answer the question either way and still get credit. The worst thing to do is what why it does. Put down no and move on. You can't do that. You got to give a reason why. Okay? You do, no, I'm not even grading yours. Wrong. Okay. It's wrong. Moving on. No, not everyone. That'd be mean. Okay. Don't be mean about it. Don't be mean about it. All right. This one looks hard. Why? What page is this going to be? Wrong go, bucko. All right. Find the total variation. Blake Howard knows this page number. Blake Howard has it written in his notes. Cassidy. 5 what? I don't know. Is it? Why? Open your book. And I know her book. She's going to let you do it for her. You also go to the back of the book and look up total variation. If you go into 522. What's on 553? Give that a go. Did you look on page 553? You look up variation in the index, and then total is a subheading. Total variation.
Total variation.
Yeah.
All right, what is it?
Total variation.
Right.
Oh, let's see. Explain variation. Is that what you're talking about?
Is that what we're talking about? The explainer of the total?
It's something to see one minus
Y minus Y bar squared.
Why are we finding that? And what's the coefficient of determination?
All right, so what's the equation coefficient of determination?
Explain variation and total variation.
Explained over total. So what is he explained?
653.
Explained is what? It says the explained derivation is 0.84. Oh, you already did it? 84 over the 128.6. That's because you're on the right page.
You got a little confused because you were looking for something else.
I was. I just want to see if you can find the equations. The question I asked, find the coefficient of determination. Isn't that r squared? Okay. What do you get when you divide them?
653.
Perfect.
So what's the left thing?
This, that's also total variation.
So we don't have to worry about that, we just leave it right, like, explain the total.
Right. One of the questions, yesterday asked for total variation. This one's asking for the coefficient of determination. That page answers both of them. All right, so we'll stop here for the day. Finish it up for tomorrow.